Good morning. Hi, everyone. Lower the volume a little bit. There we go. All right. I'm starting off today by, let's see, okay, by refactoring my two bucket solution. I had finished solving the two bucket exercise on exercism.io, and I did that with some pretty ugly code. I was kind of in a hurry to finish it before the end of the stream, and I did, right? Let's see, make sure all the tests are passing. Yep, but the code is pretty ugly. So let's see. I've got, what am I doing here? This is what I want to refactor primarily. The run function, which is, as you can see here, has a complexity of 15. You must be kidding. A bunch of if statements in there. And okay. So, and there's like checks that I'm doing all over the place, more than once, as you can see. So, okay. Let's just run through this again. Remember what I'm doing. I'm starting buckets at 0, the other buckets at 0. Starting bucket capacity is if this starter bucket is 1, then the starter bucket capacity is bucket 1 capacity, otherwise it's bucket 2 capacity. And I'm doing kind of the same thing here. The bucket capacity if the starter bucket equals to 1. And I'm doing the same check here, and I'm doing the same check here. So how about we just store that here into a is starter bucket is starter bucket or is bucket 1 starter bucket. I could just store that like this. Yeah, I could do that. And I could just replace all of these with this. Like that. And then here. Actually, we'll rename that to bucket 1 is starter bucket, which makes for a nice if bucket 1 is starter bucket, right? Now, I wonder if I shouldn't just refactor this as well. Let's just go let's just run the tests first. Yep. Okay. Let's see here. Like, I'm tempted to make a bucket class, you know? The weird thing is that we already have this thing here that our test is forcing us to use as some kind of identifier. Although I might be able to let's see, we're checking this, we're checking equals to 1, so and this really could be anything. So I could choose to have const bucket dot 1 be a bucket implementation. That could be an interesting way to, okay, let's, you know what, let's just forget about this for now. And what if I did what am I doing? Class. And that's going to say bucket refers to a value. What if I were to, would that screw things up? Could I have a bucket interface along with a, how would TypeScript deal with this? No, I think it doesn't. Just, this doesn't get, this doesn't become any JavaScript code. Neither does this. So I think that's how it deals with that. So, okay. What do we need our bucket to have? It needs to have a capacity, right? Capacity, and that's going to be read-only. Capacity, well, yeah. Except for in the constructor. So read-only capacity, type number, and then we need a read-only what are we going to call this? We're going to call this current level, I guess. What else do we need? We need an ID. it's going to be a type string. Okay. And let's start with that. So when we build this thing, we need to pass in a capacity. So let's make this capacity. Are we going to need? No, so we can just go read only. Capacity. Actually, do I even need to have this public? Not. Do I need to have any of these public, actually? Huh. Might not. So let's forget about this for now. And let's just think about doing this. Private capacity. I need private current level, which is going to start off as 0. They start off empty, so I'll put that last, I guess. And I need an ID. Let's put the ID first. There you go. Private ID. Well, I can. No, that I'm going for sure to need to access from the outside. So private. No, just read only. So public. Do I need the public, or can I just do read only? I think I can just do read only. Read only ID of type string. Private capacity of type number. Okay. Like that. All right. So if I was, let's just, let's comment all of that out. And just, well, actually, I wanted to copy this first, but let's do that. Should have done this the other way. There you go. Okay. Ooh, what's this? Declared, never used. Yeah, cool. So what are we doing here? We're starting, our starting bucket is equal to 0, our other bucket is equal to 0. So instead of having them be equal to a number, I should just assign an actual, initialize an actual bucket. Bucket. And how do I know which one is the starting bucket? Now that is the question. Starter bucket, type of bucket 1, bucket 2. Okay, so that I can actually get rid of if I just have these initialized to a bucket. Alright, so this could just be new bucket implementation. Boom. Except that, okay, hold on. Crap. Crap. Is that gonna work? Because we're getting, where are we getting? Okay, we're getting that information here. Okay. So then we can't have it as in the constructor. We need Well, I mean, we can, but we need all right, let's think about this. We could have, oh, we could use like singletons. This could be interesting. Because the first thing we have in our tests is we're assigning starter bucket equals bucket one, and then we pass in the starter bucket to this thing. How do we just pass in, so if reference is not enough, we still need a check. Oh, but I'll have the ID, so. So what if bucket one would be a reference to a function that when called returns what? Returns a new bucket implementation. Doesn't really make sense, or does it? So basically like a factory. Then when we're creating this here, we can just do new. So basically I could just pass the constructor. Does that make sense? Am I complicating things here for no good reason? Might very well be the case. Alright, let's just skip that part and try to implement. Let's see, if I were to just instantiate these, we're keeping this the way it is. And we are starting buckets equals 0. So let's instead call this starting bucket would be new bucket implementation. We need an ID, so this is where we would simply go this dot starter bucket. Perfect. We assign 1 as starter bucket capacity. How do I retrieve the correct capacity? I've got bucket 1 capacity here, bucket 2 capacity here. I still need a check. Oh, that's annoying. That is very annoying. Although I could have all of this stuff in the constructor. Maybe no, I can't. I can't. So I'd essentially need to do this. You know, inside the bucket implementation. Well, I mean, I could make this, okay, I could make this into a function. That wouldn't be the end of the world. Extract to method in class 2 bucket. We'll call it determine bucket capacity. Yeah. And determine bucket capacity would actually not look like this at all. We're returning a number. We're taking in bucket ID. ID of type string, and we return if bucket ID is equal to 1, then we return this bucket 1 capacity, otherwise we return this other one. Okay. Then I could just forget about all this here and do new bucket implementation, this starter bucket, and then this dot determine bucket capacity, this dot starting bucket, starter bucket. And it starts off with 0, so that's cool. Now how do I do the other one though? Now new bucket implementation. I need the opposite of this starter bucket. Huh. Yeah. I don't like where this is going. Don't like where this is going. Nope. Don't like any of this. Oh, that's interesting. Why is this stuff all commented out? Got one comment here, one comment there. Glitch in the matrix. Apparently. Okay, there we go. Although, wait. I think I screwed up my parentheses here. In iNico, it's TypeScript. The language is TypeScript. What the heck did I do here? Oh, that's what I thought. Right, so I just want to do this like that. And I'll take this. X. And shove it in here. Like that. Got one too many. There we go. Okay. So I think that's right. Yeah. I would love for these to be the actual instances of my bucket. I think it would save me a lot of time and make the code cleaner. So how about we just instantiate them and okay, let's start with doing that and then we'll see how we deal with the rest. How would I go about instantiating bucket implementations right away when I don't know? Yeah, I just need a way to set these property elsewhere than in the constructor. Except for, I guess, the ID. So let's just get rid of this. Do this like that. Boom. Okay. I think that works. Then all we really need is some kind of a setter, maybe. Set. No, I don't want it. Initialize, we'll call it. Initialize. Then we'll pass in capacity. Number. Okay. This dot capacity is equal to capacity. Do I need to change the current level? Not in here anyways. So let's leave it like that. Okay, now if I were to so I've got current level set to 0. I'll enter okay. So if I do new bucket implementation here, pass in the string 1, new bucket implementation, pass in the string 2, we used before, right. right. Doesn't like that, does it? Put that at the very top, I guess. Or maybe just before. Yeah. See how far we can get with that. Now, that's probably going to screw up our what do I have here? Type of QBucket starter bucket. We'll simply put now bucket implementation, or bucket actually. Bucket should have, I've got a public function in here, so it should have initialize capacity number void. And read only, so it also has an ID. ID type string. Okay. Right. Now, it could be interesting, well, in the test itself, okay, let's think about this now. We already know which one's the starter bucket. So we don't need to deal with this. Already have it. The other bucket though, actually I could do that in our constructor. I like the idea of doing that. Okay, let's bring this back here for a second. How about we just do this right here? And we could even have a there's already another bucket thing here. I really don't like the way this is implemented, but this is forced on us. Go bucket needs to be type of bucket ID. Does that work? Oh, no, because that refers to, that's interesting. This should work. Don't need the dot. Now go bucket is just a string. Whatever, let's just make it a string for now. Figure the rest later. If I am to, let's see here. Yeah, let's just do that in the constructor for now. Take that out of the run function. So all I need is somewhere else to store the, so I'll make it private. There we go. This is a public. I'll just make it private right here. That we are going to call the other bucket. The bucket is of type bucket. Cool. And now we just do some kind of check where if, actually probably use this, so this dot other bucket is equal to starter bucket, actually this dot starter bucket is equal to, no, the starter bucket dot ID, there we go, is equal to 1. If it's equal to 1, then we want this other bucket to be, we need to make it equal to this, no, simply to bucket dot 2. Otherwise, bucket dot 1. Think that'll work. Cool. So now we have both of our buckets, starter and other, taken care of. Now bucket capacity is, well, we should be setting that right in here as well. So this dot starter bucket dot initialize this will set the capacity, but how do I know which one? I need to check the ID. Ugh, that is a lot of crap. Set the other bucket. Alright, let's do that. Alright, let's do that for now anyways. So if this starter bucket is dot ID is equal to 1, here's what we do. We initialize starter bucket dot capacity. No, dot initialize. That's how we do it. I'm just gonna forget about that for now. We initialize it with this dot bucket 1 capacity, and we can just do other bucket dot initialize this dot bucket 2 capacity, because we know that's how it is, and if it's not the case, then we know that it's the opposite. Ugh, this is so ugly. Okay. I don't see any other way to do this for now. Oh, I need this to be into an else, of course. Okay. I could probably, since I'm making that check here anyways, I could probably offload that to this right here, other bucket equals bucket 2. And then just do, well, I'm actually adding an extra line. If I do forget that, then I guess. Let's leave it like that. Okay. All right, now I've got my, don't need this anymore. So while starting bucket is equal to this dot goal. So while this will be replaced with, okay, so I do need access to the well, I could make, actually I could make starting bucket is equal to this dot goal is not equal to this dot goal. So in other words, okay, let's make a function on here that we're going to call is not goal, or is not, or has not reached goal, or bucket has not reached. Hey Lumi, how you doing? Or simply goal not achieved. Goal, I don't like negative, so goal achieved. Well, let's just do it like that then. Or if goal, for reached. That's a Boolean. So goal not reached. We simply need to check that, oh, we need to pass in the goal. Oh no, we don't. We've got it as a, oh yeah, we do, because, wait, where, oh, there's the goal, okay. So we need to pass in the goal. As a number. And we simply do this dot goal does not equal to this not goal. What am I doing? Just goal is not equal to this dot current level. Yeah, I don't like this. We're checking for something that's, so what would be better, doing this and not having to negate the check in the if statement, or actually doing this and let's just do that. Turn this. Okay, so then I can just do while this dot starter bucket goal reached. I have to do this, and this dot other bucket that goal reached. These are pass in goal, this dot goal. Okay. If other bucket is equal to other bucket capacity, okay. So we can call this bucket full. Bucket is full. Or just, sure. Bucket full. Bucket is full. Should also say goal is reached. That would be better. Okay. So bucket is full. That I don't need a parameter. This is simply a matter of doing this dot capacity. This capacity is equal to this dot current level. Add this here. Bucket is full. Returns a boolean. Alright, so now I can just do if this dot other bucket dot is full. No? Other bucket, right. Dot bucket is full. Well, I could just call it is full. Is full. Is full. This could be renamed to has reached goal. I like it. Has reached goal. Alright, if this other bucket is full, then we empty the bucket. So we need a method called empty bucket. Empty. Just empty. Doesn't return anything. And it simply goes this dot current level is equal to 0. So alright. This dot other bucket dot empty. Right, then put it in the interface. Let's do that. Empty. Okay. And then this is a counter on here, so that's fine. Now if starting bucket is empty, so this dot starter bucket dot is empty. This is also, there we go. Let's put it here. is empty, returns a Boolean. We just need to do return this dot capacity is equal to 0. All right. Add it to our interface here. Is empty. Crap. Boolean. Okay. All right. If starter bucket dot is empty, then starting bucket is equal to starting bucket capacity. So we fill the bucket. Let's have a method for that. So fill void. And this dot current level will now become the same as this dot capacity. Okay, so now we do this dot starter bucket dot, need to add it to our interface. Fill void dot fill. Cool. There should also be a negation here. Now, available space in another bucket equals blah, blah, blah. Okay, this I think I can rewrite. What am I doing here? If starting bucket is smaller or equal to available space in other bucket plus equals starting bucket. So we're essentially what are we doing? Let's take a look at our little diagram. Transfer starting bucket to other bucket, right? Is that what we're doing here? Starting bucket, other bucket plus equals starting bucket, yeah. Okay. Let's see here. It'd be interesting to make like some sort of Fluent API for this. Something that's like transfer. Yeah, transfer starting bucket to other bucket. You know, something like that. That'd be cool. Or it could be straight on the other bucket. So it could be this dot starting bucket dot transfer 2, then boom, other bucket. This dot other bucket, but that would mean that the bucket needs some sort of way to, yeah, that could work. I like this. Let's do that. Well, let's think about this for a second here. You know, I think that could work. Okay, let's do a transfer to. I'm keeping my checks here, so let's just do transfer to. And this will be a bucket. Am I returning anything? I'm not. Okay. So then I could just put that. Let's keep the same order here. Initialize is empty is full, and I'm putting transfer to should be after these two. Okay, empty, fill, and transfer to. Transfer to. Let's get this down a little bit if I'm gonna slouch. Transfer to the other bucket. Bucket. Void. Okay. This is also void. Now what do? We need to, well, if I'm looking at this, what are we doing here? That's interesting here. We are checking to see if there's enough space we're looking for the available space in the other bucket. Okay. And then if the starting bucket can fit, if it can fit in there, we add it. We completely empty it. If it can't fit in there, we fill up the other bucket and we reduce the, okay. All right, so all of this can be basically moved to the bucket class. But I think a transfer to, now that I'm thinking about it, I think a transfer to function would not belong on the bucket, but more, because that means the bucket needs to be aware of another bucket. And that's kind of weird. It would make more sense on the two bucket class. So I revise my position on this. So let's instead make a, so let's go with my transfer idea. I could either make just a one function, take the first bucket, second bucket. But I kind of like my Fluent API idea. How would that work? I'd simply go transfer, and then you take a bucket of type bucket, and then you would need to return an object that has a method called to, right? Which would be well, we could return a to bucket. We could return this. Think about this. No, that doesn't make sense at all. Let's just keep it simple. So, bucket from, or let's call it from bucket. Transfer from of type bucket, and to bucket. It should work. Then I can pretty much just take all of this here. Yep, let's get rid of this. Shove it in here. Just call this dot transfer. From this dot starter bucket to this dot other bucket, which really I don't need to do because that's always going to be the case. So I can pretty much just say transfer, not even pass in anything. But I could do transfer from starter to other. Sure, let's do that. Just so that we understand what's going on. Don't need these, thank you. Then I do need to check for that. Available space in other bucket. So I should have a read-only available space of type number. This will be a getter. Put it here. Get available space. Turn a number. And this will be a simple matter of doing this dot capacity minus this dot current level. Although this now leads to confusion because available space versus capacity. What's the difference? So let's make this. What could I call this? I could call this size. The bucket size, yeah. Let's do that instead. Okay. Turn this. So now available space in another bucket. I already have access to that. I can just do if this dot starter bucket, this dot starter bucket dot okay, I need a way to get this at the current level, I guess. Or do I? I could simply have a fits in function, because that's really what we're trying to do here. Could have a can transfer to and take in a bucket. Right, something like that. And that would return a Boolean. Let's try that. See if we like it. So can transfer to a bucket type bucket. We're getting Boolean from this. So we're basically taking this dot we get into the same problem though. We need to access the other bucket's available space, which, oh, no, that's good. We did make that a getter. So what we're doing here is we're checking that, where is it? The starting bucket level is smaller than the available space in the other bucket. Okay, so we can do this dot current level smaller or equal to bucket not available space, and that's just a parameter. Yeah, I can actually return that. All right, and then in here I would just go if this dot starter bucket dot can transfer to this dot other bucket. Then what do we do? We other bucket plus equals starting bucket. We add the starting bucket to the other bucket, right? So we would need a, let's see, this is fill. Let's add. Add liters of type number. could just pass in the, no, let's do that. Again, now that I think about it, this makes sense that this needs to be aware of the other bucket. It makes for a nice API, I guess. I can just pass in the other bucket instead of having to do this other bucket dot current level and exposing the other. Yeah. Whatever. Works for now, anyways. All right, so we add. And here again, we could choose to no, we're just going to do add. And this will be leaders. Void. And we're simply doing this dot I would need some kind of a check. So okay, if this dot size minus this dot, oh, I do have available space here. So if available space is smaller than leaders, throw new error message. This is OMG, I'm overflowing. Let's just go bucket is overflowing. Let's go with that. Otherwise, we're good. We can just add our thing there. So this dot current level. Oops. Current level plus equals leaders. So now this can be replaced by this dot, oops, what am I adding here? The other bucket. Okay, so this other bucket dot add the dot starter bucket dot, oh, and that's the thing, right? Well, the entire thing, I guess. This other bucket dot add this other bucket. Dot capacity? Nope, I don't have that size. I don't have that. I'm going to have to expose. I'm going to have to expose something here. We need the size or the current level. Let's make the current level. Let's make a getter. Get current level. Return start current level. All right, so now I can do starter bucket dot add that this starter bucket dot. Actually, I have an idea. Might be able to hold off on this. Oops. Let's delete that. And we might be able to do instead. Okay. Like this. Const level equals this dot current level. And this and then return level. Let's call quantity being poured out. Of that. That seems to be the problem. Number is not assignable to type void. Oh, yep. Sorry about that. There we go. Okay. So now I can just do, if this starter bucket can transfer to this other bucket, cool, this other bucket dot add, this starter bucket dot empty. Here we go. And don't need to do this here. Now, else. So if the starter bucket cannot transfer to this other bucket, what do I need to do? I need to, is other bucket capacity, basically fill up the other bucket and reduce the starting bucket by the available space in the other bucket. So I would need a remove the right. Yeah, why not? Remove leaders void. Then we'd go remove liters number void. Again, I would need a check here. This dot current level is smaller than the amount of liters. I'd throw a new error. Or yeah. Throw a new error that says, dude, the bucket does not even have that much in it. Okay. And if that's not a problem, oh, wait, if this current level is bigger, no, smaller than liters, yeah, okay. This available space is smaller than liters when we want to add it. Yeah. So here we can just do this dot current level minus equals liters. So now here I can just do other bucket is equal other bucket capacity. All right, so basically we're just filling up the other bucket. This dot other bucket dot fill, and we are removing the available space in the other bucket from the starting bucket. So this dot starter bucket dot remove the, how do we get the available space? Do I have access to that? I do. Okay. I think that's a getter. I probably available space available. There it is. Okay. Okay, so we got remove here. So I think that's good. Let's look this over again. So if this starter bucket can transfer to this other bucket, then this other bucket dot add the starter bucket dot empty. Else this other bucket dot fill. Right. And this starter bucket dot remove this other bucket dot available space. Yeah, das ist gut. Uh-huh. Okay. Now, what is that? That's our goal thing. We need to update the goal bucket. And we need to update the other bucket the public other bucket property here. So if I was to just replace this crudely, it would look like if this dot starter bucket dot has reached goal, the goal number, this dot goal. And then if this starter bucket dot ID equals 1, then this goal bucket goal bucket equals bucket dot 1 dot ID. Now let's go bucket dot 2 dot ID, and this other bucket equals this dot other bucket dot quant dot current level. Oh, so I do need to expose this. I just don't have a choice. I just don't have a choice. So let's do it. Let's call this a read-only current level type number. Get current level type number, return this dot current level. All right. So current level. Now else, if this starter bucket dot ID equals 1, and this gold bucket is equal bucket dot 2 dot ID, else this gold bucket dot ID, and this starter bucket dot current level. This is horrible, but whatever. Well, I managed to reduce the complexity a little bit with all this refactoring, but still, look at this, just to deal with when we reach the goal. I'm not liking this at all. But at this point, let's check to see that we're still passing our tests and that we didn't horribly break something. Uh-oh. Uh-oh. Looks like we're stuck in some sort of infinite loop. And we did break something. No. No. Yeah, okay. Feel free to break out of this. I guess I'll take care of that boat. All right. Well, that bites. Oh, wait. How am I breaking out of this? When I reach the goal. Right. If this other bucket is full, this other bucket is empty, this moves. If the starter bucket is empty, this starter bucket dot fill. That's what we're doing here, isn't it? Yes. So these, I'm pretty sure, are sound. This transfer from starter to other. If this starter bucket dot can transfer to this other bucket dot add, this starter bucket dot empty. Empty. Is the current level equals 0. Quantity being poured out equals this current level. Quantity being poured out. Add. If this available space is smaller than liters, throw an error. Otherwise, this current level plus equals liters. Remove. If this current level is smaller than liters. Otherwise, this current level minus equals liters. This all seems good so far. Here comes this. Can transfer. This current level is smaller or equal. Nope, that's not right. Yeah, okay, bucket available space. And available space is this size minus this current level, yeah. I don't see any obvious problems here in my code. Goal is equal to this current level, yeah. Oh man, I'm gonna have to debug this, ugh. Ugh. Did not. But I was so careful. Is it and? If and, yeah. Both buckets are starting at 0. Alright, let's debug this. Man. Actually, before I do that, Let's try Quokka on this thing. Let's use this here. Actually, using Quokka might not be a good idea, because if I run into an infinite loop, it's just going to hang and forget that. Okay. Let's forget that. We're going to go straight to actual debugging. I just need to set this up in here. 12 days. No, that's not the one. We want 2 bucket. 2 bucket. To bucket.test.ts. Okay. Now how do I go about starting this thing here? I gotta go to debug. Let's do it here. Launch program. Ah, crap, didn't set it. I didn't set a breakpoint. And I've got a bunch of tests too running at the same time. It's not a good idea. So let's just use this one here. Ah. Alright, so test dot only. And let's set a breakpoint right here, I guess. Okay. This seems to not be working at all. All exceptions, maybe. Let's try that, see if we hit something. We don't. Okay, stop. How about, oh, yeah, I think, let's see if I try to set a breakpoint in here instead. See what happens with that. Okay. Ugh. Might be something wrong with my config. Yeah, I'm probably missing some stuff here so that I can do this. And I don't really feel like, don't don't really feel like doing that right now. Spending the next half hour trying to figure out what the correct configuration is for this. All right, so I'm going to put this on hold for now. I mean, I could use console logs. This might quickly give me an idea of what's wrong. Yeah, I could try that just quickly. That I'm willing to do. I think I just saw a flaw in my if starting bucket is equal to this dot goal. This should be outside the while loop, right? Yes. And I've got it inside the while loop, I think. Let me see here. No, I've got it outside. Okay. So obviously our condition here is never being reached. Why would that be? Probably because there's a problem with something here. So how about we do each turn of our while loop. It's almost as if though it doesn't even get to it. Could that be why this dot run, running this, running the while loop, while we haven't reached the goal. Alright, so let's do this. Console.log. Gonna log the let's make it nice starter bucket. Starter bucket. So that doesn't seem to be well. Let's just call it that. This starter bucket. Other bucket. This other bucket. See how. See what we get when we try running this. Problems, trailing white space, don't care. We're not even getting anything because it's, right. Well, do we even get to? Okay, I don't get it. I don't get it. It's as if we're not even getting to our run function. Or would it? It's probably because jest holds off all the console. Oh, that's a pain. Yeah, that's probably it. Probably just holds off all the console's output. until it's done, and then it just dumps it. And since we're not, so forget that, eh? All right, fix this some other time. I'll still commit this, and we're going to call this refactored to bucket need to debug as it is stuck in an infinite loop. Yes, I am committing code that doesn't work. Not exactly good practice, is it? All right, let's move on to another one then. And when I'm not streaming, I'll fool around with configuring the debug for this thing. Variable length quantity unlocked. Let's check this out. Implement variable length quantity encoding and decoding. The goal of this exercise to implement VLQ encoding data. Don't even know what that is. In short, the goal of this encoding is to encode integers, integer values in a way that would save bytes. Only the first 7 bits of each byte is significant, write justified. Sort of like an ASCII byte. So if you have a 32-bit value, you have to unpack it into a series of 7-bit bytes. Of course, you will have a variable number of bytes depending upon your integer. To indicate which is the last byte of the series, you leave bit number 7 clear. In all of the preceding bytes, you set bit number 7. So if an integer is between 0 and 127, it can be represented as 1 byte. Although VLQ can deal with numbers of arbitrary sizes, for this exercise we will restrict ourselves to only numbers that fit in a 32-bit unsigned integer. Here are examples of integers as 32-bit values and the variable length quantities that they translate to. Okay. This will be interesting. A lot of interesting new concepts in there for me. So let's download that. Variable length quantity install. Variable quantity. To encode integer values in a way that would save bytes. Only the first 7 bits of each byte is significant. Write justified, whatever that means. So number 0, variable quantity 0, 0. Oh, that's what they mean by write justified, I guess. Seven F is 7F, 80 is 8100. Ugh. Oh, right, but that's using that's not in binary. That's in what do you call this? Hexadecimal, I think. Right? So there's 16. It's like base 16, I think. You got like 1, 0 to 9, and then A, B, C, D, E, F. So 0 to 9 is 10, then A, B, C, D, E, F. Yeah, so that's like a base 16 thing. Okay. Let's just add variable length quantity exercise. All right. Let's take a look at our test case. All right, so we're using a default export and a static method. In code, we pass in, what is that? An array that has, oh yeah, what is that? That's the way to describe hexadecimal, isn't it? 2 single byte values maximum. So you can do that, right, in JavaScript. Let's take a look at, if we were to open this, let's just run Quoke on it, and do 0x, how was this described again? Zero x 40 is 64. Right. Why? Because it's 16 times 4. Right, if it's base 64, if it's base 16, then the first position can be, so 4 times 16 would be 32, 30, yeah, right. Because if I did 1, for instance, then that would be 65, yeah, okay. If I did 5, then it would add 16 to the 64. Yes, that's correct. Okay. And I think this is called hexadecimal. Never really used it before though, but I have a vague understanding of how it works. Base 16 system used to simplify how binary is represented. A hex digit can be blah blah blah. So I'm probably going to refer to that again at some point. Oh, it's already almost 11. I'm not going to have time to do much with this. Let's see. Producing a series of bytes. A byte is normally 8 bits, isn't it? So how, let's go back to our instructions. The goal of this encoding is to encode integer values in a way that would save bytes. Only the first 7 bits of each byte is significant. Right, justified, sort of like an ASCII byte. So these are 1, 2, 3, 4, 5, 6, 7, 8. They're 8 bytes, but in base 16, in hexadecimal. Which is why they are 32 bits instead of 8 bits. Is that... They're the equivalent of 32-bit, I think. I don't know. Yeah, okay, they are. That's 32-bit values. Okay. The variable length quantities that they translate to. So if you have a 32-bit value, you have to unpack it into a series of 7-bit bytes. All right. Which I take it to mean, why is this a 7-bit byte? So this is a 32-bit, this is a 7-bit, 7-bit. If I do, I basically have 16, 2. So the maximum thing I can represent here is yeah, it's 127, right? Because I can do 16, basically 16 times 16. No, that's not right. I can do, let me think about this here. So if I have, let's say I have F here, and then I have F here. Yeah, that would be 255. Why? If an integer is between 0 to 127, it can be represented as 1 byte. Oh, as 1 byte. Oh no. What? Let's read this. Okay, so if you have a 32-bit value, you have to unpack that into a series of 7-bit bytes. 7-bit bytes. Of course, you will have a variable number of bytes depending upon your integer. To indicate which is the last byte of the series, you leave bit number 7 clear. In all of the preceding bytes, you set bit number 7. So if an integer is between 0, you can represent it as 1 byte. Yeah, I'm confused. It's going to require some reading on my part. And research. Well, to start with, what are we getting fed as? Okay, we're being given actual actual 8, well, not 8-bit, but 32-bit bytes, right? So we're being fed 32-bit integers. All right, so I'm gonna have to research this because there's something I'm not quite getting here. And I'm out of time anyways for this stream, so I'll be able to do that and come back to it some other time. So we're gonna leave that right here. And next time, hopefully I will have set up the debugging for my 2-bucket exercise, and I'm going to try to read a little bit on this thing here, see if I can get a better understanding of it. Till next time.